All right, here we go. All right, homework for tonight. All right, special segments. Three constructions today. Three constructions. These are definitely medium difficulty. So make sure you fully understand. You might have to watch parts of the video a couple times. So I usually start this off by this is a picture of the literal meter. And it was proposed by a group of countries that got together and they decided that this specific distance was going to be a meter. Now, if that's a meter, then what's a centimeter? So you need to take that distance right there and break it up into a bunch of little parts. And each one of those parts has to be the same size. Now, obviously, you can do that with a compass, but how big is each individual piece's part? And so our first construction is basically going to show you how you can make a ruler if you so choose. So how do you take a given distance and break it up into equal parts? So if you wanted to take that and break it up into 10 equal parts, or for instance, in the centimeter, 100 equal parts, this is what you're going to do. We're not going to break it up into 100 equal parts. We'll do something a bit easier. So historical thing in 1875 is when they established the length of a meter. And there's the actual physical object that they used to make the meter. All right, so the first construction we're going to do is divide a given segment into equal parts. Now, if we break it up into, say, 2 equal parts, we already know how to do that. Just make a perpendicular bisector. If you divide it into 4 equal parts, we'll just do that procedure twice. But let's say you wanted to break this into 3 or maybe 5 equal parts. Well, you can't break it into half and do something. You need another technique. So this is that technique. All right. So as always, I'll show you the steps, pause the video, come back, we'll do the construction. All right. So here we go. Here will be the construction. Set this up. Okay, so here we go. Here's the construction. So step number 1, it truly doesn't matter whether you go above or below, but and it doesn't matter if you use point A or point B. I'm right-handed, so I always choose the left point. If you're left-handed, choose the right point, just so you have space to work. So I'm going to make an angle. So from point A, I'm just going to make an angle. Now, how far do you make the other leg of the angle? A good distance. Okay, easy first step. Next step, I'm going to take my compass and let's see. We can do this as many parts as we want, but let's break this up into 3 equal parts. So I'm going to break AB into 3 equal parts. Now I can do the guess and check method. 1, 2, oh, not enough. Open it up. That would be guess and check. But here's a way to get it right the first time. So I'm going to open this up to any distance that I can fit 3 equal parts onto the leg of the angle I just constructed. So I need to make it a little bit smaller, and I'm going to break this up into 3 parts. Now, I don't care if I get to the end here. I just need 3 equal parts. So I'll put the point on A, make an arc. There's 1 part. There's 2 parts. And there's 3 parts. If we're going to break AB up into 5 equal parts, I would have to put 5. All right, so I've now broken this up into 1, 2, 3 equal parts. I don't care about this extra right here. If you want to make it easier to yourself, just try to use the entire length that you just made right there. All right, step number 2, I'm going to connect the last arc intersection, this one right here, to B. So with a straight edge, put my pencil on B to the arc intersection, and there we go. Okay. The rest of the construction is fairly simple. I'm simply going to make parallel lines to this line just made. So from here, parallel, from here, parallel, and it'll end up breaking AB into 3 equal parts. So let's see, how do we make parallel lines? Well, parallel lines, so I'm through this point right here, and through this point right here, I'm going to make a line that's parallel to the given one. So if you remember how that's done, it's basically making congruent angles. I'm going to make an arc through this leg and this leg from here. So an arc through here and here. And then I'm going to do the same thing for here, between here and the non-existent new line. So put the point right here and make an arc that goes through both legs. See what I did? Now repeat the exact same arc right there through, I'm going to use this, through here and here. So I'm going to reconstruct this arc that I just made, so I'm not changing this distance, but I'm going to use this point and this point now. I'm going to make the same arc. So it's going to look something like this. And then the last one, it's going to look something like this. Don't worry that you just intersected the line you're trying to cut into thirds. It's okay. Okay. There we go. All right, next step. We need to measure the distance between here and here, here and here, here and here. So I'm going to measure that distance. That looks about like, try to be accurate. Looks about like that. Yep. Once you have that measurement, I'm going to recreate this arc that I just made right here onto this one using this point, and then do the same thing for this one right there. Remember, I'm going to intersect not AB, I'm going to intersect the arcs. So I'm going to put my point right here and intersect the arc, and the point right here and intersect the last arc. I think you can probably figure out what we're going to do next. I'm going to draw a line, let's see, from this point and this point through the intersection. So from this point through this intersection of the two arcs, and if I've done it correctly, I should make parallel lines. That looks parallel. From this point through these intersections, make parallel lines. Now I've made 3 parallel lines, and it turns out that I've broken AB into 1, 2, 3 equal parts. Now, why is that true? Well, we've made similar triangles here. So we made a lot of triangles here. Small triangle, medium triangle, big triangle. And all the triangles, since these lines are parallel, alternate, or corresponding angles are congruent. So all these triangles are similar. And we know when triangles are similar that their sides are in a proportion, meaning that this piece, and this piece are all the same length, and this piece, and this piece are all the same length. And that's why it works right there. So there you go. There's construction number 1 of the day. All right. So technically that was construction 12. 2 more to go. All right. It turns out, and I think I may have made this claim earlier, you can actually do some math with your compass. And the first piece of math we're going to do is, well, we're going to solve a proportion. So how do you do that? All right, so here's the construction number 13. I'll show you the steps. There are the steps. Pause the video, write them down. All right, this one's pretty nifty. I will give you the explanation of why this works at the end. So you need to start off with just 3 lengths of your choice. 3 lengths. Just draw 3 segments of your choice. And then you need to choose a proportion. So I got 3 values. Remember, a proportion, right? I'll do it up here. Proportion is written as, I'm going to choose 2 of these sides at random. So I'm going to choose A over C. Any 2 would work, is equal to, let's see, the third side would be B over, I don't know, there's no 4th side here. This is what I'm going to solve. So if I were to put values, like measure this with a ruler, A, B, and C, it turns out this will work. So I'm going to solve this proportion right here and figure out what the unknown length, we'll call it D maybe, I guess, but I'm going to call it X. How long X would be using this. Now, I'm not using any ruler. I'm just using a construction, which is a pretty remarkable result, that I'm going to find a physical distance without using a ruler or a calculator or anything like that. For homework tonight, they're going to force you to do a proportion. They're going to give you the proportion to do. I'm just going to point this out. If they write the proportion something like, I don't know, C over A is equal to X over B, you need to put the B on the top. So flip your proportion over to make it look like this. You want X on the bottom right there. Okay, and just flip the proportion, that would do it. I think there's one like that. All right, so let's see how this works. Let's see, step number one, it says make an angle. All right, so let's make an angle. If you want to make your life easy, make it a not a very small acute angle. So I need to make an angle, I need two sides. And make your legs long. You won't know how long to make them until you actually do this. So I'm going to make my legs nice and long. Okay. All right. So here's the procedure. Now I'm going to do this proportion right here, solving for x. So I'm going to do a over c. So the next step is you go to the top left of your proportion, and whatever is there, you're going to put it on this bottom leg, the length of it. So it says a. So I'm going to measure a with my compass, trying to be nice and accurate. I'll have some students actually measure this after we're done. So I just measured a, and I'm going to trace that distance onto the bottom leg of the angle. See what I did? So if I were to label, I don't have to. If I were to label, this would be length A. Go back to my proportion. The bottom now says C. So I'm going to measure C. Oh, C is rather large. Measure C. And sometimes I'll just draw arcs just to make sure I got that's the distance. And then I'm going to transfer that onto this. And that's the length of C. Okay. The last distance is B. Now it's on the other side of the two ratios, so it's going to go on the top leg. So I'm going to measure B. A little bit larger. This is why these screw ones are a whole lot easier. And I'm going to place that onto this leg right here. So there's the measurement of B. Now, occasionally, you can kind of look here. Occasionally, you might not make your legs long enough. So just in case, I'm going to extend my leg. I can kind of get a feeling that I haven't made it long enough. You'll see why here in a little bit. So this is why step number one says make an angle with long legs. There, I know how this goes, so I know how long basically it's going to have to be. I'm kind of eyeballing it right now. Okay. So the previous one, don't confuse that one. Break a segment into equal lengths. The previous one had us connecting this piece to that piece. Well, this one's slightly different. We're going to connect this piece to this piece. So take your straight edge. This is the next step. And connect those two pieces. There we go. That looks really weird. What happened there? Was there some piece of dust or something on my straight edge? Okay, that's better. Okay. And as you can kind of imagine, what we're going to do now is we're going to make a parallel line from here, and where it winds up, this would be your final value right here. So this would be my X value that I'm going to make right here. So all I'm going to do now, similar as the previous one, I'm going to make a parallel line from this one that goes through this point right here. All right. So how do we do that? Once again, I need to make an arc from here that goes to the two legs of this angle right here. So any distance is fine. I do this so you can see what I'm doing. Arc there, arc here. And then to do the same thing down here, make that complete arc. Since I don't know where it's going to wind up, I'm going to draw the complete arc. Unlike what I just did. Okay, so why did I make a complete arc here, not one right here? Because remember, all I'm looking for when you're making these parallel lines is this intersection and this intersection. But I don't know where that intersection is going to wind up here, so I'm going to make a complete arc. I guess you could ignore this part right here because you know that won't be the case. All right. Second to last step, I'm going to measure the distance between the arc and leg of the angle intersection here and here. So measure that with your compass. All of these kind of like flow together in the sense of what we're doing each time. That kind of makes sense right there. And then transfer that down from here. Not from here, but from here. So point right there. Trying to be accurate, draw my arc, and there we go. And now you can probably see why I had to extend that one originally. Okay, last step from here through there, and I hope I made it long enough, and I didn't make it long enough. I even got to go longer. So I wasn't joking about make an angle with long legs. There we go. So from there, my straight edge isn't long enough to get all the way over there. But I can do it in 2 shots. 1, 2. There we go. Now, if I were to measure the distance from here to here, that would be the measurement of x, and that would be the value that went right there. All right, I promised you I'd explain why this works. So why does this work? Once again, it's similar triangles. Notice both the small triangle and the larger triangle share this angle. There's your first A for angle. And since we made parallel lines, then corresponding angles congruent. There's my second one, so angle. So the 2 triangles are similar. So remember the pattern. Top over bottom would equal this one over this in your proportion. This over this would equal this over this, and that's why it works. Okay. All right, there is your construction right there. All right, 2 down, 1 to go. The last one, once again, it's going to be another calculation. I don't know if I've made the statement to you in this on these videos or not, but I know I've done it in my other class. And then when I started constructions, I said what we would end up was I was going to show you how to do square roots with a compass, which is kind of crazy, the fact that you can take a square root with a compass. So how does that work? It's the last construction. I'll show you the steps, copy them down, and then we'll do the construction. All right, so should I start with why this works first or just do the construction? All right, so I'll just give you a brief introduction. I mean, pick any number that you want to take the square root of. Let's say we want to take the square root of 20, right? If you can rewrite 20 as 2 numbers multiplied together, let's say 4 times 5, and then you could with you got to have a ruler, right? If you can make 2 segments, one of length 4 and one of length 5, it turns out you can take the square root of 20 using this method right here. I mean, we're literally going to get the distance that's equal to the square root of 20. All right, so how does that work? Okay, well, this is the construction. Okay, step number 1, make a long segment. The segment needs to be as long as these 2 pieces put together. All right, so construction. I need a little bit more space here in the bottom. So make a long segment. And then what you're going to do on this, and it doesn't matter the order that you do it, you can put A first or B first, it doesn't matter. I'm going to trace those 2 distances onto the segment. So I'll just do them in the order that they're listed right here. So here's going to be A. Measure that distance, that's the distance. Place it right here. You don't need to label, but you can if you want. So there's A. And then I'm going to measure B. It's that distance. And then I'm not measuring from here, I'm measuring from the end right here. So I'm linking up A and B onto one segment, trying to be accurate. So there we go. I don't need this extra distance right here. You don't need to erase it if you don't want to. I'll just leave it right there. Okay, so there's step number 1. On a new segment, construct A and B. All right, nice. Next step, I'm going to make a perpendicular bisector between here and the end of where B is, not to here. In fact, I could erase from here to here if I wanted to. So I'm going to make the perpendicular bisector of from here to here. So remember, perpendicular bisector, I forget which construction this is, open it up to more than halfway. And this is the only one where you actually do need arcs above and below, the perpendicular bisector. If you're making a bisector through a point on a line, you just need arcs above. If it's a point above or below, you just need arcs on the opposite side. But this is the one where I literally need arcs above and below. So remember, open it up to more than halfway. I need arcs above. I need arcs below. And then not from this end, because remember, I didn't need this part from here. Same distance, make your intersecting arcs. So intersect, intersect. Okay. Now, I don't need to necessarily draw from here to here. I just need to see where it intersects the segment. So at this intersection right there, all I really need is that. Okay. All right, next step, we're going to actually draw a circle. And well, it's actually a semicircle. Doesn't matter whether the semicircle is above or below. Most people put it above. If you look in the book, that's what they do. So, all right, got a lot of arcs going on here. Pay attention. Here we're going to, from this perpendicular bisector, we're going to measure from here to either the end of B or the beginning of A. So I'm going to measure to the end of B. And this is going to be the radius of the circle I'm about, or semicircle I'm about to draw. So there's that radius. So with that distance, I want you to draw a semicircle from A to the end of B. And like I said, most of the book included, they draw it above, but it could be below if you'd like. So draw my semicircle. All right. Okay. Let's put some more arcs in here to make this more confusing. All right, so now I'm going to ignore this right here, and I'm going to look at this intersection right here. So remember, this was the intersection where A ended. Okay, so from this intersection right here, I'm going to make a perpendicular that goes up to the circle and stops, or the semicircle and stops. So what you're really doing is you're making that construction where you have a segment, and you have a point on the segment, and you're making a perpendicular right here. When I draw the perpendicular, it's going to be from here to the circle and stop. All right, so how do we do that? We're going to have lots of arcs here. We put our point right here, and I need arcs to the right and arcs to the left of your distance of your choice. So I want to keep them on the segment, so I'm going to make them so that they actually fit. So I'm just kind of test fitting right there. That should be a good distance. So arc here, I'm going to make it a little bit dark so I remember, because there's going to be lots of arcs here. And an arc here. If you want to make it all the way to the point, and point A, the start of point A, you can. And you see I've got arcs everywhere. So it will, I just made this arc, and I made this arc right here. Okay. With this point being the center. All right. So once that's done, you open it up to more than halfway. Well, what would be halfway? Halfway would be from here to here. There's half, so a little bit more than that. That'll work fine. And I don't need arcs above and below. I just need either one, above or below. But I'm going to be drawing a line from here to the circle. So I'm going to try to put my arcs below, unless it interferes with these two arcs and I'm a little bit confused. So remember, I'm opening up to more than halfway. And it looks like I'll be okay. So arc right underneath here. I know it's going to be there. And then I'm going to this one. You can get absolutely confused with all these arcs. All right. So there's my intersection. I'm going to draw a line from here through here to the circle, but all I really need is the distance from here to the circle. So I'm going to line it up, but when I actually draw, I'm only drawing from here to the circle. See what I did? And drum roll, please. It turns out that this distance from here to here is the square root of A times B. So if we wrote the square root of A times B and you measured A and B with a ruler, it turns out that this distance from here to here is that square root, is the answer to that right there, which is a fairly, we'll call this X, which is a fairly remarkable claim. So I better prove this to you. Otherwise, you're gonna think I'm full of it. All right, so let's see. How can I prove this? How can I prove this? Okay, this is pretty slick. Now, this isn't part of the construction. You're done with the construction right here. X is the square root of A times B now. So how can I prove it to you? Here we go. Watch this slickness. If I connect this point right here to the start of the segment, and I connect here to the end of the segment, right, which was right here. Okay, we've made an inscribed angle to a circle. And since This right here would be the diameter of the circle, 180 degrees. We know this is a right angle. Remember, inscribed angles are half of the arc. And this gets really slick. Watch this. We haven't done this for a while. If you have this construction right here, which I just did, there's the triangle, and you drop an altitude straight down. How do I know this is 90? Because remember, I made it perpendicular. This is that weird construction from a couple chapters ago called the geometric mean. And we know that if I call this x right here, we know that x is equal to the square root of, you remember the pattern? It was this piece, which I just called a, times this piece, which was called b. Remember, the thing in the middle was the square root of this times this. Well, there you go. That's why this works. That's kind of nuts that this is, we're doing a square root with just a compass and a straight edge and a pencil, and you actually did it. Now this seems a little I don't know, it's a little bit of a letdown because we were expecting to get a number here for x, and that number would be the distance. I mean, if I measured it now, well, I don't have a ruler. If I measured from here to here, that would be the square root of these two lengths. If you have the time and you have the willingness to do this, then make a segment of length 4, make a segment of length 5, do this construction, now measure x, and then type in the square root of 20 in your calculator and see if you get the same thing. And it should be, now notice the construction has to be done perfectly for it to come out perfect, but you should get a number that's pretty darn close within the decimal place, or tenth or a couple tenths of the right answer. So that's pretty slick. And believe it or not, we're not done with the chapter, but that's the last official construction that we're going to do. We're going to do some other constructions, but well, I won't spoil it, but they're not going to be any new thing that you have to remember or to have to write down steps for. All the rest are simply going to be using the constructions, it's technically 15 constructions, because remember, construction 1 had a 1A and a 1B. So it's 15 constructions in the chapter, and we just finished the last construction. The rest of the chapter, there's 3 more sections, has to deal with another concept that, well, we'll just wait until we get there. All right, as always, if you have any questions, don't hesitate to ask. And with that, I'll end it, and I'll see you on the next class.